Precalculus, Unit 1, Day 5, coming up. Okay, we're going to start off with some simple stuff, just some Algebra 2 review. We're going to add and subtract some functions, right? So first off, let's look at the symbolic language that they use here, the shorthand of it. So like if I have f of x and g of x, two separate functions, and I want to do something with those two, this is how I can write it. So if I want the sum of those two functions, I could write f plus g of x. This is not f plus g times x. This is f of x plus g of x. Okay, I'm not adding the letters f and g and multiplying them times x. If I want the difference, I want to subtract, I can write f minus g of x, which is the same as f of x subtract g of x. Okay, so some shorthand notation here that can save you a little bit of time in writing all of that out. Okay, if you're going to multiply two functions, okay, f times g of x is the same as writing f of x times g of x. And f over g, or f divided by g of x, will be f of x divided by g of x. And since the denominator can't equal 0, then they have to throw that in every time that g of x can't be 0. Okay? All right. So this little piece here says that the domain of my new function. So what new function? Well, if I say f plus g of x, then f plus g is my new function. If I say f times g, that's my new function. So whatever my new function is, okay, it consists of those values of x that are common to the domains of both f and g. So it has to be a point that, or a value that works in both f of x and g of x. So if it works in both, then it's in the domain of your new function, whether you added the original two or subtracted or multiplied by. All right, so let's look at example A. They give us f of x is x minus 4. They give us g of x is the square root of x plus 3. Okay. This first one may be a little bit too good to be true, a little too simple, but that's okay. So f plus g of x, which is the same as f of x plus g of x. Well, f of x, it says, is x minus 4. And I'm just going to put parentheses around it just to separate them. And then g of x already has its grouping symbol, square root. Okay, so that's f of x plus g of x. So when I drop my parentheses and I write this out, x, 4, and this square root, none of those are like terms. So guess what? You're done. That is f plus g of x. Okay, let's go with f minus g of x. Again, that's f of x minus g of x. F of x is x minus 4. We're going to subtract the square root of x plus 3. And you guessed it. We don't have to do anything else for this particular question. That is f minus g of x. Too good to be true. I know I told you, okay? But that's all right. Let's keep working with it. Number 3, f times g of x is f of x times g of x. Okay, so f of x, again, is x minus 4. G of x, again, I'm not going to use any other grouping symbols because the square root is a grouping symbol. Square root of x plus 3. Okay, now, we do have to actually do a little bit of simplifying on this one. Okay, you have a binomial multiplied by a monomial. So we're going to have to use the distributive property. So you've got x times root x plus 3. So that would be x root x plus 3. And then you have minus 4 times root x plus 3, so minus 4 root x plus 3. Those are not like terms. Okay, obviously, if you wanted to factor out your root, you'd go right back to there. Okay? And that's a good answer right there. So far, so good. F divided by G. Right, well, that's f of x divided by g of x. Okay, so f of x, again, is x minus 4. G of x is root of x plus 3. Okay, now, a couple things. First off, I am aware that we didn't do this part here. We're going to go back and find the domains of all of these. Okay. Secondly, there's a square root in this denominator here. So at this point in time, we don't like square roots in the denominator. We like to rationalize our denominators. By the end of our semester, we won't care a whole lot about rationalizing the denominators. But for right now, we are usually not going to allow square roots in the denominators. But for this one question, we're going to let this one go. And we're going to leave it right here just so that we can keep it as simple. It's only for the sake of the explanation. Okay? So we're going to leave it here. And now we're going to go back and talk about the domains. Right? The domain of this first function, which we said was x minus 4 plus root x plus 3. Actually, let's just go right here. So x minus 4 plus root x plus 3. All right, so first off, what is the domain of f? The domain of f, well, there's no square root with x in it, and there's no x in the denominator. So the domain of f was all real numbers. And that was kind of nice. What about the domain of g? What was the domain of g of x? Well, the domain of g of x, well, g of x does have a square root. Okay? There is a square root. So if you remember from earlier in this unit, the square root has this thing called the radicand underneath of it, and the radicand has got to be greater than or equal to 0. It cannot be negative. So we solve, okay? So that right there is the domain of f plus g of x, okay? That's the only restriction that we have. The only restriction at all is that there's a square root. If you look at f minus g, we have the same restriction, okay? It was x plus 4 minus root x plus 3. Again, f has no restrictions at all on its domain. G does have the same restriction here. Okay, so the domain is that x is greater than or equal to -3. And if you want to write that as integral notation, it'd be -3 to infinity, including the -3. So that's good on both of these. Okay. What about number 3? Number 3. Well, we have the same f and the same g. So we do know that you have this same domain to think about. Now, the only question is, are there any extra restrictions after we multiplied the two functions? Are there any extra restrictions? All right. Restrictions: square root with x's under it, or fraction where x is in the denominator. Well, we have the same square roots that we had in the beginning. So there are no new restrictions on this. So the only restriction that we have is that the square root can't have a negative number. So once again, we've got -3 to infinity as our domain. That's for x's. That's our domain. Okay, now the fourth one Okay? Again, we have the same restrictions on F and G, right? So we just have to make sure of one thing, and that is that this new function, this brand new function that has a square root in the denominator, that they cannot equal 0. Okay? So we know that the G restriction tells us that x is greater than or equal to -3. But we also know that the denominator, cannot equal 0. So square root of x plus 3 can't equal 0. Well, that means that x plus 3 itself cannot equal 0. So guess what we do? We subtract 3 from both sides, and we find that x cannot equal -3. So what is that going to do to our domain? Well, I can't write this for one reason. The one reason is this says it's greater than or equal to. Meanwhile, it says it cannot be equal to -3. So greater than or equal to can't be, just greater than. Okay, this right here tells me it can't be an equal to. So when you look at your final new function, in this case we have a square root in the denominator, we absolutely positively need to take care of this one and say that we're going to take that thing out. We're just going to say x is greater than -3, or we can say -3 to infinity, but this time it's a parenthesis because it cannot equal the -3. Okay, a lot of stuff to chew on right there. Let's go to the next type of combining of functions. We've added, subtracted, multiplied, and divided. Now we're going to compose functions. Okay? Again, you should have done some of this in Algebra 2, but we're putting functions inside of functions. All right, so the notations, there are two ways to note composing a function. The one that I think just makes more sense is this one. It says you take f of x, but instead of using x, we're going to substitute whatever g of x is for where my x was. Okay? So instead of f of x, it's f of this other thing, g of x. So you're just going to substitute g of x in for x. Okay? Notice that the outside function is the one that gets substituted into. The outside function is the one that gets substituted into. All right. Now, another way of writing this right here is probably a little more popular, I think a little harder to understand, but f of g of x can be written just like that. The f, the little hollow dot g of x. When I was in college, professors actually called this fog of x. Okay, so fog of x, f of g of x. Okay, so as long as you remember that that just means the same as this, that we're taking g of x and we're substituting it into the f function wherever there was an x. Right? Let's look at an example of that. Hopefully that'll make this easy to understand for you. Okay, so we want to find, given these two functions, we want to find f of g of x, g of f of x, and then f of g of 3. Okay, easy enough. Let's do f of g of x first. So f, and I'm going to write it like this, of g of x. Okay, I'm not going to write the fog yet. We can write it that way later if you want. All right, so we're going to take the x in f of x, and we're going to replace it with 5 minus x squared. Okay, so f of x is 3 times x plus 1. But we don't want f of x. We want f of g of x. So we're going to put g of x right where the the x used to be. Okay, we substitute it. Now we're just going to simplify. Okay, nothing terribly tough here. We're going to distribute my 3. See if we have any combined like terms to combine. We got a 15 and a plus 1. Right, so I'm going to put the x term first. Minus 3x squared plus 16. So that is f of g of x. We took the g of x and we substituted it in for the x in the f function. Now let's look at g of f of x. That one. Okay, same thing. It's just that now g of x says we're going to take 5 and subtract x squared, but it's not going to be x that we're going to be squaring. It's going to be 3x plus 1. All right. Now this one's got a bunch of little things, little common mistakes, common math mistakes that people make all the time. Okay, first off, PEMDAS says we got to do this exponent. So off to the side here, somewhere, I'll do it up in this area up here. I'm going to take 3x plus 1 and square it, which means I'm going to take 3x plus 1 and multiply it by 3x plus 1. Okay? And when I FOIL that out, I get 9x squared plus 1x plus 1x plus 1. Okay? So I'm going to keep parentheses around it. 9x squared plus 2x plus 1. All right. Next thing that people will get wrong a lot, that negative sign out in front of the parentheses. Remember, this minus goes to all of these. Okay? This minus is distributed because it's multiplying by -1 in essence. So I'm going to drop the parentheses by multiplying each of these terms by -1. So 9x squared times -1, 2x by -1, and 1 times -1. Now I'm just going to combine my like terms. Okay, I've got an x squared term, so I got minus 9x squared, -9x squared. I got an x term, minus 2x. And then I got a 5 and a -1, so that's 4. Okay. So not a deep or tough concept here, just a lot of little things that people can do wrong. You know, squaring the binomial, not distributing the negative. Okay, those are common math mistakes. So hopefully we fill those gaps. So now that we have f of g of x and g of f of x, now we just have one more question to answer here. And that is, what is f of g of 3? So we can write that as f of g of 3, if we wish. I'm going to give you 2 ways of doing this, okay? The first way, since we already have f of g of x, I'm going to take the 3 and I'm going to substitute it for x, because that's what we want. We want f of g of 3, not f of g of x. So because we already did the work for f of g of x, I'm going to say f of g of 3 equals -3 times x squared plus 16. But we know that we don't want 3 x, we want 3. So now we're going to go ahead and we're going to simplify. So PEMDAS says exponents first, so that's 9 times -3 is -27 plus 16, which gives me -11. Okay, so that's one way to do it. If you have f of g of x already, that's probably the easiest way. If you don't, okay, then let me offer you this. Okay, this you may think is a little easier, especially if you haven't done the f of g of x already. Okay, So f of g of 3. I would actually do it this way if I were starting off. I would first find, let's put a 3 in there. Okay. I would actually find what g of 3 is. What is g of 3? Well, g of 3, I would put the 3 right there. Okay, which means I'm going to put 3 right there. 5 minus 3 squared. Okay, so 5 minus 9, that tells me that g of 3 is -4. 5 minus 9 is -4. So now I can take the -4 and I can put it into my f function. So f of -4 is 3 times x plus 1. But I'm not going to use x, I'm going to use -4. So 3 times -4 is -12. Plus 1 is -11. Okay. So there's 2 different ways to do it. Take your pick. I think that this one is nice if you haven't already gotten f of g of x, but if you did already get f of g of x, have at it. Domains of composite functions. Okay, well, once again, we're going to look at the restrictions of both functions. Okay, you look at the restriction in the one that you plugged in, and then you look at the restrictions of your final function. Okay, so let's check out g of f of x. First, we got to find out what it is. It says find g of f of x. So g of f of x says I'm going to take f of x and put it into the g function. Okay, so the g function, g of f of x. Okay, so the g function says I take something, I square it, and I subtract 1. So I'm going to take something, square it, and I'm going to subtract 1. Okay. Now, don't be alarmed. This one is easy to simplify, because what is the f of x that we're going to substitute in for x? It's just square root of x plus 1. Okay. Now, when you square a square root, squaring and square root are inverse operations. They cancel each other out. So that means you just have x plus 1, and then bring down your minus 1. So that means g of f of x is x. Interesting. Okay, well, what does y equals x look like? You know, it's a parent function. It's a line, goes through the origin, has a slope of +1. Are there any restrictions at all on y equals x? Nope. No square roots, no denominators with x in them. Okay, so there are no restrictions on f of g, but it says right here, please make sure that you remember that the inside function has to be taken account of as well. If the inside function that you plugged into the other function has restrictions, they still have to be included. So what is g of, what is the inside function looking like here? In this case, it's f of x. F of x, oh baby, that's got a square root. So we know from our first quiz that we have to say the radicand must be greater than or equal to 0. Subtract 1, we get x is greater than or equal to -1. Or we can say, -1 to infinity with a bracket. Okay. So find g of f of x. It equals x. We got it. State the domain of the new function. The domain of the new function is greater than or equal to -1 or -1 to infinity. Reason, even though g of f simplifies down to something that doesn't have a square root in it, the original function that was inside f of x, that did have square root. So we had to do our domain restriction regardless. And now the very last thing that we're going to look at is decomposing function. So we just did composing functions, where you have an f of x and a g of x, and you compose them into a third function. You could call it h of x if you wanted to, like here. H of x is f of g of x. Well, now they're just saying, instead of composing it, we want you to decompose it. I'm going to go backwards. Now they're giving you what the h of x is, and they say, we want you to figure out what the question could have been to get us to compose two functions where you get 1 over x plus 7. Okay, so let me see if I can explain this in a way that I think makes sense to you, or hopefully will make sense to you. So when you set it up with your decomposing like this, you see that the g of x is actually inside of the other function. So in order to decompose, you must have something that's inside of another function to give you, the new function. Well, what do we have here? We have a fraction. Okay, we have a fraction. And what's in that fraction? In the fraction is an x plus 7. So I would say that in is x plus 7. I'm going to say that the in here for the g of x is x plus 7. So if I put x plus 7 into another function, it's going to give me this. Well, what would I put it in for? I would have to put it into the denominator of a fraction of 1 over this denominator. Well, let's do that. 1 over. So what would I need to make in my f of x so that if I replaced x with x plus 7, I get this? Well, it would just be x. Okay, think about it. If I gave you this as a question up above, and I said find f of g of x, okay, I would take the g of x and I'd put it right there, and it would be 1 over x plus 7. Well, that's what we got. Perfect. Okay. Now there are more than one. There are more solutions than just one for most of these here. I like this question a lot because I think it's pretty straightforward. Number one, I think there's a 1 over something, and that something is the x plus 7. So I'm hoping that one is pretty clear to you. So you get x plus 7 for g of x and 1 over x for f of x. All right, now let's look at h of x. Number 2, h of x, that is. What do we get? Well, as I said, there's more than one solution to stuff like this, but I would say that we have an x minus 1 that's in a square root. Okay, so one option could be that the inside one, the g of x, could be x minus 1, and that's in the square root. So what would f of x have to be so that if I put this x minus 1 into it where x is, that it looks like that whole thing? I'm hoping that you can see this. Okay, if this whole thing were an x and I replaced it with x minus 1, okay, then I would look like this. So if I could say square root, and that's where I want the x minus 1 to go. So that's my x, because I'm going to substitute it. But then there's this plus 2. So I just have to put plus 2 outside. Think about it. F of g. I would put the G inside of the F, and I would get your original question. Okay? Now, just to show you that there are more than, there is more than one answer here. There are more than enough ways to do these things. Check this out. Same question. Let's do it a different way. Let's just say that I look at it as this thing is in an addition question. Okay. This is something plus 2. Okay. So I'm going to call g of x root of x minus 1. Okay. So that's a something. That's a function. So what would I have to replace to make that h of x? Well, it's that thing plus 2. It's this thing plus 2. So I want to put that square root right here. So this is another way you could do it. Okay? As I said, more than one way to do these questions, but I like both of those. I think probably the first one, because there's a square root, and we would just take the radicand and make that one of your functions, the inside function. I think that might be a little more obvious for you, but they're both good. Okay. All right. That's it. We're done. Day 5. See ya.